All right, so we're going to talk about horizontal asymptotes again. Remember when we talked about speeds the other period? Remember that on Friday? We talked about speeds of a function. So if you had like an x squared and an x cubed, which one moves faster? The x cubed. And if the x cubed is in the denominator, then what was our horizontal asymptote? Y equals 0, because the bottom grew faster. All right, if they're the same z's, we look at the what? The coefficients. Now we're going to talk about functions that aren't just polynomials. So, I actually like to think of it going this way. I like to think about it going up. So in pre-calc and calc AB, we really are talking about different functions. And usually I start with logs as the slowest moving, but really it's just a number, and then our trig functions, and then logs, and then polynomials, then exponentials. All right, but usually I start at logs, polys, expos. Factorials are actually a BC topic, and we won't really do that in this period either. All right, cool. So we talk about speeds of functions. So let's look at this first example. I have the limit as x approaches infinity, so I'm talking about those horizontal asymptotes again, but I have sine x over x. Well, what's the limit as sine x over x? What's that equal? 1, not this case, because it's a limit as x approaches what? Infinity, not 0. If the limit as x approaches 0 of sine x over x, that would be what? That would be 1. However, it's to infinity. So now we need to look at the speeds of these functions. So I have a trig function over a polynomial. All right? So this is the way you kind of think about it. What can sine go in between? What's sine always in between? -1 and 1. All right? So up top, I'm always going to have -1 to 1, right? And if it were just sine, what would it do? It would oscillate between those values. And then if it's a number, -1 to 1, over a really big, then it would be what? The limit to infinity would be 0. All right? Because the bottom grows a lot quicker than between -1 and 1. All right, it's a number over really big. All right, let's look at part B. So now I have a limit as x approaches negative infinity. And so if I substitute a negative infinity, I really have like e to the negative infinity minus 2 times negative infinity, yes? And then this is my childhood going on. E to the negative infinity, where does it get to go? The basement. All right, so then I have 1 over e to the infinity. And then if I have minus 2 times, -2 times negative infinity, what's a negative times a negative? Positive. So this is really like plus infinity, right? It's not 2 times infinity because that's the same thing. Because infinity is a direction. It's a concept, right? All right. So then what is 1 over e to the infinity? What does this go to? A number over really big. So what does that go to? That goes to 0. So then I have 0 plus infinity, and we're going to call that infinity. Now, let's talk about limits real quick. Let's put them out. What's a limit? When you do what? Approach from both sides, arbitrarily close to a number, a y-value number. Do they have to touch? No. Are they allowed to touch? Yes. There's 4 reasons a limit doesn't exist. 1, jump discontinuity. 2, increasing, decreasing without bounds. 3, 4, fantastic. Now, my answer is infinity. Does my limit actually exist? No, it doesn't exist. How else could I say this? It doesn't exist because why? It increases without bound. All right? However, in today's lesson, we are going to call it infinity. What this really means, when I'm talking about x's, this x to negative infinity, which way am I moving? I'm moving left. And as I move left, this is my y value. It goes which way? Up. So that's what the descriptor is. Now, does the limit purely exist? It does not. All right, because it doesn't go to a y value number. All right, let's look at this next one. So now I have limit as x approaches infinity. So if I substitute infinity, I have 5 plus 2 to the infinity, 2 minus 2 to the infinity. So I'm looking at speeds. I have exponentials. They're growing at the same speed. So now I look at the what? The bases. I look at the bases. So what does it go to? 2 over negative 2, which is negative 1. All right. However, I want to show you something. If I have a limit as x approaches infinity of, let's say, 5 plus 3 to the x over 2 plus 4 to the x, well, I need to look at my speeds, right? So are they the same speeds? They are not the same speeds. So here's an example of it. If I substitute in 1, don't worry about the 5 and the 2. Those aren't going to, remember how you add to it. When we get really big, it's not going to matter, right? All right. So then if I have 1, 3 to the power 1 is 3. 4 to the power 1 is 4. So how far off am I right now between them? Just 1, right? Now if I do 2, so now I have 3 squared. 3 squared is 9. 4 squared is 16. Oh, crap. How much did that separate by? That separated by 7. And if I do 3, I end up with 27 over 64. And that's even more than 7. So what's happening? Which one's growing faster? The bottom grows faster. So that would actually be 0, because the bottom grows faster. And it's a little bit different when we actually do like x squareds, right? When I had this the other day, when I had a function like that, I just looked at the speeds, right? These are both the same polynomial. Remember that? And then I looked for what? The coefficients. So those coefficients for limit to infinity would be what? 3/4. However, on that kind of exponential, I grow a lot faster on the bottom. Does that make sense? All right, these are actually the same speeds because they're both the same base. Okay? All right, cool. So let's look at part D. So now if I have a limit as x approaches negative infinity, I kind of have something like this going on. I got 5 plus 2 to the negative infinity over 2 minus 2 to the infinity. Yes? Negative infinity, sorry. It's a negative exponent again. What happens? It goes to the basement, but the whole thing doesn't go to the basement. It's really like 5 plus 1 over to the infinity. And then it's like 2 minus 1 over to the infinity. Right? So then when I do it, this 1 over to the infinity actually goes to what? It goes to 0. I got a number over really big. So that part goes to what? 0. And if I have a number over really big, that part goes to what? 0. So what am I left with? 5 over 2. All right. So that's saying as I move left, my y value is going to even out at 5/2. All right, pretty cool. All right, we're moving. All right, let's look at these. So we kind of did these on Friday already, but we're going to do them again. So if I have a limit as x approaches infinity of this guy, I need to look for the speeds. They're both polynomials, so that's all cool. So which ones grow faster? Where's my higher power? They're the samesies, so then what do we look at? Coefficients. So what do we get? 1 over 4. All right. So f, I now have a limit to x approaches negative infinity. So it's the same, right? So it's 1 over 4. No, dog. What happens here? What happens? If I substitute a negative infinity right here, what happens? My negative cancels, right? So now it's positive up top. But what's going on the bottom? It's going to be negative. So it's really like 1 over negative 4. We don't usually call it negative 4 in the denominator. We usually call it what? Negative 1/4. All right. Pretty good. So the sign cancels up top, but it doesn't on the bottom. Remember those from the other day? All right. To be talking about. All right. So now we're going to talk about a definition of a vertical asymptote. So what did I say made a vertical asymptote pretty much all year? A what? A number over 0. A number over 0 makes a vertical asymptote. True? And then we know that the limit isn't going to exist at a vertical asymptote. True? It's going to either do what? Increase without bound or decrease without bound. Now this lesson tells us that we can call increasing without bound what? Say infinity. And then it's going to decrease without bound. We're going to call it what? Negative infinity. So that's what we're going to do. So this is going to be kind of like a new tool in your toolbox. All right. If you get a number over 0, you can utilize this new tool in your toolbox. And our answer is going to be negative infinity or positive infinity. It's going to be one or the other, so you just guess. All right. Just kidding. We're going to go over techniques of how to do this. All right. So anyway, are you going to use this tool every single time? No. Only when you get a what? A number over 0. A vertical asymptote is when you're going to use this tool. Okay? All right, cool. If you get 0 over 0, what should you do? You did 3 things before. You either factor, or you rationalize, or you little fraction. Remember? All right. So this one's our new tool. All right. So now we're going out when you get a number over 0. So let's look at this. So now I have a limit as x approaches 0 of 1 over x. And I'm doing it from the left. Okay. The little minus sign means the left. What's left of 0? Like negative 0.01, like a really small negative. You get it? All right. So this is the way you can look at it. I have a positive number up top over a really small what? Negative. What's a positive over a negative? Negative, right? So if it's a positive number over a really small negative, I end up with negative infinity. So if you pick 1 over like negative 0.01, all right, it's going to be like negative a million. I don't know. Depends how many zeros you put in. Okay, you following me? And the closer and closer you get to 0, it's going to be even bigger and bigger. All right, a bigger negative, I should say. All right, let's look at part B. So now what do I have going on up top? A positive number. And if I go from 0 from the right, it's over a really small what? Positive. So a positive over a positive is a positive infinity. Because it's a number, a positive number over a really small positive, that's going to be positive infinity. Pretty good? All right, put that into practice now. So let's look at part A. So we're going to find vertical asymptotes, find the limit from the left and the right of all of these vertical asymptotes. So the first one we have is x squared minus 1 over 2x minus 4. Anytime I can factor something, I'm going to do it. All right, so let's factor that top. So what's the top factor to? X minus 1 and x plus 1. Over, I'm going to factor out the bottom a little bit too, if you're cool with that. What could I factor out? 2 times x minus 2. So what number would give me a vertical asymptote here? When will I get a number over 0? 2. So my vertical asymptote is x equals 2. Now we're going to discuss the limit from the left and the limit from the right. Now, before we even do any of this, I get a number over 0, which means what? Does my limit exist? Does my limit exist? No. All right, we know it doesn't exist. Now, what we're going to get as an answer choice is going to be like our descriptors of it. It's going to tell me as I approach 2 from the left, it's going to go up or it's going to go down. Does that make sense? All right. All right, so now if I have a limit as x approaches 2 from the left, this is what we do. What would be like a number 2 from the left? A little bit less than 2. Like 1.999, right? 1.999. So now, if I substitute in 1.999, minus 1 would be what? Positive. True? And then this also would be what? Positive. So what kind of number do I have up top? I have a positive number up top. Yes? Over, now, it's like 1.999, right? So what kind of number would I have on the bottom? A really what negative? A little small negative. All right? So if I have a positive over a really small negative, what would my limit as x approaches 2 from the left be? Negative infinity. So that means as I approach 2 from the left, which way is it going? It's going down. All right? All right, let's look at this another one. So now I have 2 from the right. So what's 2 from the right? Like 2.01, right? So what do I get when I substitute in 2.01? That would be This would be what? What kind of positive? Really freaking small positive. All right. So what will we get? Positive over really small positive, which would be positive infinity. All right. Pretty good. All right. Let's look at part B now. So on part B, I need to figure out when we have numbers over zeros going on. So what could I do to the bottom? Let's F it up. What does it factor to? X minus 3x minus 1. Now, because I see an x minus 1 on the denominator, can I change the numerator to be x minus 1? Yeah, what could we do? Factor out a negative 1. Good. So what happened? My x minus 1's cancel. So what does that create? We talked about this the first day we did limits. That creates a hole. So I want to figure out where that hole is. So we have a hole at 1 comma something. Now the way we do it is we find a limit as x approaches 1 of this function. Remember doing this? All right. So now remember that I like to call this the simpler function. I'm going to do that this year and next year. So I like to call this negative 1 over x minus 3 the simpler function at everywhere but x equals 1. So now if we substitute in 1 here, I get negative 1 over what? Negative 2, which is 1/2. So my limit, I'm going to have a hole at 1 comma 1/2. Remember doing that the first day? That's what we did the first day. All right, so now we're talking about vertical asymptotes today. Where do I have a vertical asymptote? At x equals 3. All right, because I get a number over 0. Yes? All right, so now I'm going to take a limit as x approaches 3 from the left, and I'm going to take a limit as x approaches 3 from the right. Now, I would highly recommend just use the simpler function. You don't have to, but it's going to be easier, okay? You could substitute it all in here, but ain't nobody got time for that. You know what I'm saying? I personally would do it right here in this little simple one, okay? You're going to get the same outcomes. All right, so now from the left, what's 3 from the left? That's a little bit less than 3. 2.999, right? So what kind of number do I have up top? A negative. I have a negative up top. What do I have on the bottom? A really small negative. So I have a negative over a really small negative, which would be a positive infinity. All right. All right, let's do it on this other one. So now if I go 3 from the right, that would be a little bit more than 3. Like what? 3.01. All right. So what do I have up top? Negative over a really small positive, which makes it a negative infinity. All right, pretty good. All right, let's look at part C. So now, when am I going to get a vertical asymptote? Say it louder. X equals negative 1. Love it. All right, so now I'm going to do a limit as x approaches negative 1 from the left, and I'm going to do a limit as x approaches negative 1 from the right. All right, what's a little bit left of negative 1? Perfect. A little bit, like negative 1.001. So if I substitute a negative 1.001, what do I get right here? A negative. However, what am I doing to it? Squaring it. So now it's a positive number over a really small what? Positive, which makes it positive infinity. All right. Now if I do negative 1 from the right, so like negative 0.9, right? So what do I get on the denominator? A really small positive again. So what does that become? Positive infinity. All right. All right, so again, this is just some words of basically saying don't use the new tool everywhere. All right. It's when you get a what? A vertical asymptote, when you get a number over 0. That's when you go a little bit left, a little bit right. All right. All right. Let's do these. So I have this graph, and we're going to talk about this graph. So part A says f of 0. Is that a limit? No, that's where it's at. So where is it at? It's at -1. You know what? I want to add one. Let's do that now. If I do a limit as x approaches 0 of this function, what would my limit be? Doesn't exist. Because why? It's a jump. It's a jump discontinuity. All right, now I'm cool with jump discs. All right, part B. So limit as x approaches -infinity. What does it mean when x approaches -infinity? Which way is this graph moving? Left. So I'm trying to figure out if it goes to a value when I'm moving left. Does it go to a value? Yes. What value is that? -2. All right. Sometimes that's hard for you guys to do graphically. All right. Hopefully we can pick that up. Now, part C says the limit as x approaches what? Infinity. So that says I am moving to the right. Does it go to a value when it goes to the right? Yes. What's it go to? It goes to 0. Pretty good? So now part D is saying the limit as x approaches 2 from the right. Well, here's to the right of 2, yes? So I'm tracing 2 to the right. And so where's it going? Positive infinity. Now, I will not take off if you say does not exist, because why? It increases without bound. Those mean the same thing. Does everybody hear me on this? All right. I am not going to give you a multiple choice test. However, they're probably going to have infinity and does not exist increases without bound as far as your multiple choice tests are concerned. You'll get that next year. I'm not doing it this year. Does that make sense? So right now, pick which one you want. All right, I'm cool with either. All right, so then limit as x approaches 2 from the left would be what? -infinity. All right, or I'd accept what? Does not exist because decreases without bound. You can't just say decreases without bounds. I'm not going to take it if you give me both, because the answer is really does not exist. All right, because does infinity actually exist? No, it's a direction. It's a concept. It's not actually a number. All right, and then let's look at f. So f of 2. Do I have a value at 2? No, dog, doesn't exist. Because why? Because vertical asymptote. It is a vertical asymptote. All right, pretty good. All right, infinity homework, number 4, and then infinity practice.